Hello, Professor Cullen. I'm guessing that this is just you and me this time. I don't think anyone's going to be going back to in class to watch this since it's a makeup. But anyways, I hope you enjoy just the same. This is Constellation Telescopium. It's kind of a challenge. It's a smaller constellation, and it doesn't really have a lot of history since it's a newer one. But anyway, let me get started. This first picture is normally I start with I start with a picture of it, and then I move on to what's inside the constellation later. But I decided to start with a globular cluster that is in the constellation Telescopium. It is globular cluster NGC 6584 or Bennett 107. And NGC 6584 is a large, bright cluster that consists of a number of magnitude 15 stars. Telescopium is a small constellation in the southern hemisphere, and it was introduced by French astronomer Nicolas Louis de la Salle. I've been trying to get this right. La Sailly. It's French. I've been trying on it, but I'm not very good. And this was in the 18th century, and the name means telescope in Latin. And just because this is my first time with actually coming across someone it's new, I decided to do a little background check on Nicholas, and he was a French astronomer who spent his time in between 1750 and 1754 studying the stars of the southern hemisphere from the Cape of Good Hope, which is in the far south of Africa. In his years there, he was said to have observed over 10,000 stars using just his half-inch refractor. Due in large to his work in Africa and the voyages in between there, he would later identify 15 of the 88 constellations we know today. And I also found out that he was an abbot, and from my old days in Bible college, basically back then there was really only three things you were going to be if you could go to school. That was either a priest or a doctor or a lawyer, and he wanted to be more of a scientist, and so usually they became abbots. And an abbot is just it's a fancy word for saying the head of a order or a church, and but they weren't. They were the ones that were scientists weren't really the head of. They were more of an honorary abbot. And so that's what he was. He was studying to be a priest, but instead he decided he liked science and astronomy, and so he went with the whole abbot thing. So that's how that works. Alpha Telescopi, blue and white subgiants lying about 249 light years from Earth, is the brightest star in the constellation, and that's right here in the corner of it. And this picture gives a good showing of how there's really not a lot here. Mostly it's just space here with obviously some stars and then the back and some objects, and then right up here in the corner is the actual constellation, and then right here is NGC 6584, which was the picture in the very beginning. So that's south of the constellation. And here's another picture just to show you what's around it. Here's Era, and here this is the swoop of Scorpion, I believe, and here's Sagittarius. So right kind of crammed in here is Telescopium. And this is a great picture of Telescopium. This is how this is the best picture I could find. This is how it looks, or how it's meant to look for us. Telescopium is usually depicted as an aerial telescope, a long refractor suspended from a pole, and the constellation sits between much larger constellations like Sagittarius, Scorpius, and Era. And here is part of Sagittarius, and then here's the Scorpion. And then here's Ariel. So, alright, the constellation Telescopium occupies an area of 252 square degrees and does not contain any stars with known planets. It can be seen at a latitude between plus 40 degrees and negative 90, and it's best visible at 9 p.m. during the month of August. Okay, next, and lastly, and next, I would like to show you a clip from a video. It's funny how this always works out, but I love to surf YouTube and just watch like interesting documentaries and stuff. And anyway, it just seems like ever since I started this course, when I'm working on a chapter, I'll find something just happenstance. I'll just be going through, and I find something on the internet that just correlates with that chapter. And this couldn't be more true with this one. It was actually at the very end of a long, like hour-long British science show, which is really good. So if you want to watch the rest of it, of course it's going to be posted in my references. But anyway, this is near the end of it, so I was actually just watching. I was like, oh my gosh, I'm just going over this in chapter 7. So this is correlates. It doesn't really have anything to do with Telescopium, but it correlates with chapter 7. So without further ado,
seeing into this part of the spectrum is helping us understand more than our own planet. It's revealing the mysteries of the entire universe, answering some of the most fundamental questions of all. Look up into the night, and even if you're lucky and it's a clear one, there's not really that much to see. Stars, a few galaxies maybe. But that image we have of the night sky is very limited, because beyond that visible picture, there's another, far more detailed one. But to see that for yourself, you need help. You need one of these, a telescope designed to see the invisible. Telescopes like this one at Jodrell Bank are transforming our view of the universe, allowing scientists for the first time to see into the depths of space far beyond what our eyes can see. This is an image of our Milky Way in the visible spectrum. Visible telescopes can do much better than the naked eye, but there are still large areas of it that appear entirely dark. That's because much of space is filled with, well, dust, basically, cosmic debris from dead stars, and this dust blocks our view. So this is pretty much the limit of what we can see, with a bit of assistance, in the visible part of the spectrum. But now, a new generation of telescopes are able to look at that very same image of our visible Milky Way in other parts of the spectrum. From radio to gamma rays, X-rays, and infrared. These aren't just a series of cool images. They offer a more revealing picture of our universe. Take this area of space. The visible spectrum reveals a shadowy gas cloud. But seeing into the infrared reveals a dense concentration of stellar material. This is the very process that forms new stars. 5, 4, 3, 2, 1, the dawn of the space age has allowed scientists to see even further into the invisible sky. Telescopes in orbit around the Earth can detect light from the furthest parts of space, like X-rays and gamma rays. Here's another image of the visible sky, but seen in X-ray, it revealed this. This extraordinary image shows nothing less than the death of a star. You'd think that space was empty and quiet. Actually, it's violent and dynamic and explosive. This is the control room at Jodrell Bank, still at the forefront of modern astronomy. But on top of the discoveries of this generation of telescopes, there's a whole new generation of monster telescopes being built to see even further into the invisible. And now they're helping probe one of the most fundamental and intriguing mysteries of the universe, the presence of black holes. Now, I don't wish to be alarmist, but according to theory, there should be a supermassive black hole right at the centre of our own galaxy. A central dark mass around which the galaxy was formed. But, well, how do you find it? Sounds obvious when you think about it, but seeing a black hole is an immense challenge for the simple reason a black hole doesn't emit any light from any part of the spectrum. In a sense, it's the ultimate invisible object. So, finding it is, as you'd imagine, quite tricky. Unless, of course, you've got one of the world's most powerful invisible telescopes. And here, in the high Andes of Chile, that's exactly what this is. Looking into the infrared, astronomers began probing deeper and deeper into one tiny and precise patch of sky. And finally, they discovered a collection of stars apparently locked in orbit around a vast area of nothing. They'd found it, a supermassive black hole, 3 million times bigger than the Sun, right at the heart of our own Milky Way. Being able to see what was once invisible helps us to unlock the great mysteries of the universe, where it came from, where it's heading, and the sheer scale of a cosmos where our Sun is just one lonely star in a galaxy of 100 billion. And our galaxy just one of 100 billion others across the known universe. But even if planet Earth is just one tiny planet in that vast, vast universe, seen across that invisible spectrum, from ultraviolet to infrared and beyond.
Okay, wow. Actually, I guess I was wrong. That has everything to do with. It's only the second time I watched it, and I was all focused on the infrared and radio waves and everything, but that pretty much was all about telescopes. So I guess it does kind of fit in with this constellation of the week. But anyway, that was the end of the episode, pretty much. Anyway, so like I said, it was at the end of the episode, so that's a hour-long part, or 45 minutes that in the beginning where they talk about light spectrum and stuff. So if you want to watch it, it's posted here. Anyways, thanks again, Professor Cullen, for everything. I know I've emailed you a million times, not trying to like suck up to you or anything. I just really did enjoy this class. It really made me want to get. It makes me. I think it does that to everybody that probably takes this class. They want to get back into like, astronomy like they were, like when you're a kid and you just really are into that stuff. So anyway, I just really enjoyed class, and I really do appreciate the help that you gave me over the last couple months. So anyway, have fun skiing and snowboarding it up next season, and thanks again. Bye.